top of the screen. You're watching the Weather Channel. Weather you can always turn to for accurate, dependable weather forecasts 24 hours a day.
The following program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
Holy cow! Oh, the weather classroom.
This is the Weather Classroom, the Weather Channel segment that teaches you a little bit more about weather than just looking at the daily weather maps. We try and go a little bit more in depth and give you a bit of a background to appreciate weather, meteorology a little bit more. Today's focus is clouds, and we'll connect the clouds with the weather forecasting and how the weather begins to transpire from time to time. Dennis Smith will be back to talk about satellites and the role they play in photographing the clouds and also in weather forecasting. Well, let's take a look at the cloud formation. There are different types of clouds and different types of cloud formation. The sun is out here, but what this shows you is that pretty soon, if the sun is out, especially in the summertime, you're going to have puffy cumulus clouds. The air rises up into the atmosphere and those clouds form. So rising air is the key, and rising air is cooling air in the atmosphere. So as it cools, we get a puffy cloud which will blot out the sun. That's one type of cloud, one type of rising air. Also, looking at fronts, warm air rises up over a frontal boundary, a warm front, over cooler air. That rising air can give you clouds, and this cool front undercutting warm, humid air makes it rise. That'll give you lines of clouds and maybe showers too. Also, moist air rising up a mountain slope will give you cloud formation as well. There's a picture of some, let's say, summertime or springtime air that's already moist. It's rising up. It reaches a level at which the dew point is reached. We have condensation, saturation, and tiny little water drops that even look like smoke will originate above that. That's the cumulus cloud that we often see. High up in the atmosphere, generally ice clouds are called cirrus clouds, 20 to 30,000 feet and even higher. The lower clouds, called stratus clouds, generally below 5,000 feet, layered clouds, thus the strata sort of a word, and the big heap of clouds. Cumulus, the Greek word meaning a heap, starting from 4,000 feet or even lower to sometimes near 60,000 feet. Now, more on clouds. Here's Lisa Spencer.
A cloud is a condensed mass of water vapor above the ground made of ice crystals, water droplets, or a combination of both. Clouds are classified by their appearance. Here are a few. Mammatus clouds are shaped like a pouch. They are an indication of extreme turbulence in the upper levels of the atmosphere. Mammatus are a strong sign of approaching severe weather. A cirrocumulus pattern is rare. It's also called a mackerel sky. The clouds are thin, usually forming between 20 and 25,000 feet in the atmosphere. Cumulus are puffy and often resemble cotton balls. They mean fair weather. These clouds are made almost entirely of water. Cumulonimbus clouds are thunderstorms in the making. They are large with boiling tops. The sky behind the cumulonimbus may be blue, but don't be fooled. Violent weather, even tornadoes, may be on the way.
Geostationary Operational Environmental Satellite, it's abbreviated GOES. GOES satellite is a position of the satellite, looks back down basically at the North American, South American continent, the Western Hemisphere, located well above the Earth, in fact about 22,500 miles, takes a snapshot back at Earth, and as it's constantly rotating around the globe as the globe rotates on its axis, the end result is always over the same general place. So we're always going to be seeing satellite photographs, in our case for the GOES satellite, right over the North American and South American continent. Now there's two ways to take the photographs. One, with the day-lit hours of the day where the sun is illuminating that part of the Earth. We call that visible satellites. And the photography can allow us to see some features like dense fog along the coast of California, maybe some snow on the ground. Definitely we can see the clouds and even the white sand, some of the geographic features and geological features on our map. To know more about how this works, here's Bill Keneely.
NASA launched its first satellite in 1960. That enabled meteorologists to see the first weather pictures from space. Today, there are two types of satellites used for gathering weather information. First is the polar orbiting satellite, which loops around the Earth. The satellite can see an area 1,000 miles wide. On every loop, the satellite covers different territory as the Earth rotates. Second is the geostationary, or GOES satellite. The satellite is in orbit 23,400 miles above the equator. It rotates with the Earth, so it gives a constant view of North America. In the past, there have been two GOES satellites, but one of them failed. It's scheduled to be replaced in 1994. Till then, the one satellite is moved to correspond with active weather patterns, to the west for winter storms and to the east for the hurricane season. I'm Bill Keneely, the Weather Channel.
Well, we have visible satellite pictures, the ones that you see from space that look just like as if you were up in the space shuttle. Then we have the infrared variety with no color and also with color added. And when you see colors, bright colors on a map, that means these clouds are high. The infrared photography picks up on temperature, and that usually comes with the highest clouds. Let's take an example now in the whole United States. The clouds without color, and then we see them with color and actually put them into motion. A storm center moving in from the Pacific with high clouds running out ahead of it, then they get lower and lower as that storm system gets colder and colder. The clouds usually get lower right in the middle. And also some disturbed weather around Florida. Now, there is a lot more to tell you about infrared satellite imagery and how it helps in forecasting, and to do that, here's Dave Schwartz.
This is an infrared picture from a geostationary satellite. Infrared imagery measures heat given off by clouds. Some infrared pictures are colorized. This helps us understand more about the severity of weather systems. We know that the tops of higher altitude clouds are colder than cloud tops at lower levels, and that they are indicative of stronger weather. This picture shows a powerful fall storm sweeping through the center of the country. Note the various colors over Louisiana. The lighter shades at the bottom of the spectrum represent the warmest air. Clouds in this range are close to the surface of the Earth. This tells us the outer edge of the storm is made of warm, low clouds. As we move to the center of the storm, illustrated here by the darker shades, we find higher altitude clouds as the temperature drops. The higher the cloud top, the bigger the storm. This particular image tells us there are strong storms over southern Louisiana. Near Lafayette, the storm ripped apart a mobile home, uprooted trees, and knocked down power lines. Dave Schwartz, the Weather Channel.
So far we've talked about, Mike pointed out how clouds form by the uplifting of hot air rising as the sun heats the Earth, also by a front or perhaps up the slope of a mountain. We indicated how we see the clouds from space, both on a visible shot and also infrared photography. Now we're going to take you into a cloud. The best way we can do that is we could take you up in a plane up to the clouds, or we could bring the cloud back down to the ground, and that's known as fog. A good example of that would be the heat radiating off at night under clear skies and light winds, a lot of moisture close to the ground. You've seen it before, especially in some of the valley areas where that dense fog forms overnight, can really reduce the visibility rather quickly. If you ever wanted to know what it was like to be inside a cloud with the cloud droplets, that's the best example we can find. Bring the cloud right on down to the ground. In fact, to find out more about fog formation and how it affects travel, let's check that out now. Clouds way up in the sky are pretty to watch and cause few problems to most people. It's when clouds lie right on the ground, fog, they become a problem. Fog develops when air cools and moisture condenses on certain particles in the air. As the air cools, driving the relative humidity up to 100%, then more moisture condenses and the fog thickens. If water droplets that make up fog are far and few between, visibility will only be impaired slightly. But when they become more numerous, it can be a travel nightmare. On the roadway, slow up. Don't overdrive your headlights. Keep your headlights on low beams. High beams only scatter the light even more. Dense fog is also a major problem for airline traffic. The visibility reduction requires fewer landings and takeoffs, and if the fog is thick enough, can close the airport. When fog socks in airports, expect delays. The best course of action is to take along a good book. Dennis Smith, the Weather Channel. Again, the topic du jour was on clouds. We talked about cirrus clouds found high up in the levels of the atmosphere, about 20 to 30,000 feet. We talked about the cumulus clouds that are low to the ground but also can work their way well enough in the atmosphere, up to 60,000 feet. And the low-level clouds, usually in the stratus category. If you want to find out more about clouds, how about Chapter 5 in our Weather Channel classroom book? It's all on clouds.
The Weather Classroom is a production of the Weather Channel. To order the companion book for the Weather Classroom, send $9.95 plus $3.95 shipping and handling to the Weather Channel Education Services, 2600 Cumberland Parkway, Atlanta, Georgia, 30339.